Moving a breaker panel outside might seem like a solution, but there are several potential reasons to avoid it. Firstly, code compliance is paramount. Local building codes may not allow relocating the breaker panel outside. It's vital to consult a qualified electrician and local authorities to ensure compliance with all applicable regulations. Secondly, physical constraints need consideration. Installing an exterior breaker panel demands sufficient wall space and a location meeting specific clearances and accessibility requirements. It might not be feasible to find a suitable location on the exterior of the house. Thirdly, environmental factors play a significant role. Exterior breaker panels are exposed to harsh weather, including rain, snow, and extreme temperatures, which can negatively affect their performance and longevity. Fourthly, security concerns arise with exterior panels. An exterior breaker panel may be more vulnerable to tampering and vandalism than one located inside the home. Fifthly, cost is a major factor. Moving a breaker panel can be expensive, especially if it involves trenching, rewiring, and obtaining necessary permits. If relocating the panel is not the best option, explore alternatives. One alternative is enclosing the breaker panel. Creating a small enclosure around the breaker panel provides physical separation from potential hazards, such as a shower. This offers some protection and allows for easier access. Another alternative is relocating the shower knobs. Move the shower knobs to a different location on the wall that is farther away from the breaker panel, providing adequate separation. Another option is to move the breaker panel partially. Consider moving the breaker panel only slightly, just enough to provide the necessary clearance and separation from the shower area. If moving the panel outside is absolutely necessary, take precautions. Firstly, choose a suitable exterior panel. Select an exterior rated breaker panel designed to withstand the elements and rated for outdoor use. Secondly, ensure proper installation. Hire a qualified electrician to install the panel according to code requirements, manufacturer specifications, and local regulations. Thirdly, protect the panel from the weather. Install a cover or enclosure over the panel to protect it from rain, snow, debris, and direct sunlight. Fourthly, consider security. Take measures to prevent unauthorized access to the panel, such as installing a lock or alarm. Relocating electrical panels requires careful consideration of the National Electrical Code, or NEC, and local amendments. Article 110.3 B of the NEC addresses examination, installation, and use of equipment, requiring listed or labeled equipment to be installed and used in accordance with any instructions included in the listing or labeling. Article 110.12 discusses mechanical execution of work, stating that electrical equipment shall be installed in a neat and workmanlike manner. Article 110.13 addresses mounting and cooling of equipment. Electrical equipment shall be firmly secured to the surface on which it is mounted. The electrical equipment that depends upon natural circulation of air for cooling shall be installed so the airflow is not blocked. Article 110.14 discusses electrical connections. Because exterior panels may be subject to wider temperature swings, use connectors and conductors rated for the environment. Article 230 covers services. If the panel is currently fed by service entrance conductors, relocating the panel may require extending or rerouting these conductors, which must be done in accordance with NEC requirements. Article 230.6 specifies conductors considered outside of a building. Article 230.70 A1 states the service disconnecting means shall be installed at a readily accessible location either outside of a building or structure, or inside nearest the point of entrance of the service conductors. However, local jurisdictions may have amendments to this rule. Article 312 addresses cabinets, cutout boxes, and meter socket enclosures. Article 312.2 states that cabinets and cutout boxes shall be permitted to be surface-mounted, flush-mounted, or installed in suspended ceilings. However, accessibility must be maintained. Article 312.5 C addresses cables. Where single conductor cables enter a cabinet or cutout box, they shall be protected by bushings, grommets, or other approved fittings designed or identified for such use. Article 312.6 addresses minimum wire bending space at terminals. Conductors entering or leaving cabinets or cut-out boxes shall be arranged so that they do not cross over each other. Article 408 covers switchboards, switchgear, and panel boards. Article 408.3 states that all panel boards shall be readily accessible. Article 408.3 C states that panel boards shall not be located in bathrooms, toilet rooms, or clothes closets. Although this is specifically for interior locations, it suggests a concern for panel board locations in damp or potentially wet locations. Article 408.5 addresses the mounting of panel boards. Panel boards shall be mounted in enclosures designed for the purpose and shall be securely fastened in place. Clearance requirements are also very important. Article 110.26 addresses spaces about electrical equipment. Sufficient access and working space shall be provided and maintained about all electrical equipment to permit ready and safe operation and maintenance of such equipment. Article 110.26 specifies the dimensions of working space. The depth of the working space in the direction of access to live parts shall not be less than specified in Table 110.26. 8.1. Distances are determined by voltage to ground and condition. Condition 1 is exposed live parts on one side and no grounded parts or grounded parts required to be grounded on the other side of the working space, or exposed live parts on both sides effectively guarded by suitable wood or other insulating materials. Condition 2 is exposed live parts on one side and grounded parts on the other side. Condition 3 is exposed live parts on both sides of the workspace. For example, for systems of 150 volts to ground or less, Condition 1 requires a minimum clear distance of 3 feet, Condition 2 requires a minimum clear distance of 3 feet, and Condition 3 requires a minimum clear distance of 3 feet. For systems of over 151 volts to ground, but not over 600 volts to ground, Condition 1 requires a minimum clear distance of 3 feet, Condition 2 requires a minimum clear distance of 3.5 feet, and Condition 3 requires a minimum clear distance of 4 feet. Article 110.26 A2 specifies the width of the working space. The width of the working space in front of the electrical equipment shall be the width of the equipment or 30 inches, whichever is greater. In all cases, the working space shall permit at least a 90-degree opening of equipment doors or hinge panels. Article 110.26 8.3 specifies the height of the working space. The workspace shall be clear and extend from the grade, floor, or platform to the height specified in 110.26. A3. Our 110.26. A3. B. The height shall be 6.5 feet, or the height of the equipment, whichever is greater. When selecting an exterior panel, choose one with the appropriate NEMA rating. NEMA stands for National Electrical Manufacturers Association. NEMA ratings define the environmental protection an enclosure provides. For outdoor use, NEMA 3R or NEMA 4 enclosures are common. NEMA 3R enclosures provide protection against rain, sleet, snow, and the formation of ice. NEMA 4 enclosures provide the same protection as NEMA 3R, but also protect against splashing water and hose-directed water. Wiring methods for exterior installations need to be robust. The NEC specifies approved wiring methods in Chapter 3. For example, using Schedule 80 polyvinyl chloride, or PVC, conduit provides physical protection for conductors run underground or exposed to physical damage. Use of liquid tight flexible metal conduit, or LFMC, provides a flexible, weather-tight connection to the panel. When running conductors underground, ensure they are rated for direct burial, such as underground feeder or off cable. Grounding is crucial for safety. Ensure the exterior panel is properly grounded according to NEC Article 250. This typically involves driving ground rods and connecting them to the panel's grounding system with the appropriate size grounding electrode conductor. Bonding is also essential. All metallic parts of the exterior panel enclosure must be bonded together and connected to the grounding system. This minimizes the risk of electrical shock. Overcurrent protection is very important. Each circuit in the exterior panel must be protected by a circuit breaker or fuse of the correct amperage rating. This protects the wiring from overloads and short circuits. The size of the overcurrent protection device must be matched the ampacity of the conductors it protects, as specified in NEC Article 240. When trenching for underground wiring, follow NEC guidelines and local regulations. Maintain the minimum burial depth specified in NEC Table 300.50. For example, direct burial cables typically require a minimum burial depth of 24 inches. Rigid metal conduit, or RMC, and intermediate metal conduit, or IMC, require a minimum burial depth of 6 inches. PVC conduit requires a minimum burial depth of 18 inches. Protect underground cables and conduits from physical damage by using warning tape or concrete encasement. Consider the load calculation when expanding or modifying an electrical service. NEC Article 220 provides the requirements for calculating branch circuit, feeder, and service loads. Adding a tankless water heater and expanding the bathroom will increase the electrical load on the panel. Ensure the existing service has sufficient capacity to handle the additional load. If necessary, the service may need to be upgraded. When installing the exterior panel, use corrosion-resistant hardware. Exterior panels are exposed to moisture and other corrosive elements. Use stainless steel screws, bolts, and other hardware to prevent rust and corrosion. Apply anti-seize compound to threaded connections to prevent them from seizing over time. Labeling is important for safety and maintenance. Clearly label each circuit breaker in the exterior panel with its corresponding load. Use a permanent marker or label maker to create clear and durable labels. Provide a circuit directory inside the panel enclosure. After installation, inspect the work. Have a qualified electrical inspector inspect the installation to ensure it complies with all applicable codes and regulations. Address any deficiencies promptly to ensure the safety and reliability of the electrical system. Periodic maintenance is also important. Regularly inspect the exterior panel for signs of damage, corrosion, or water intrusion. Clean the panel and enclosure to remove dirt, dust, and debris. Tighten any loose connections and replace any damaged components. Moving a breaker panel outside requires careful planning and execution. Consulting with a qualified electrician is essential to ensure compliance with all applicable codes, regulations, and safety standards. Ignoring these factors can result in costly mistakes, safety hazards, and code violations. Ultimately, the decision of whether or not to move the breaker panel outside should be made in consultation with a qualified electrician and after considering all potential factors. The electrical professional can provide tailored advice based on the specific situation, local codes, and the homeowner's needs.